Very good evening, everyone. Are you able to hear me? You can respond in on the chat. So today's topic that we are going to learn is a linear search. Just give me a minute. So today's topic that we are going to learn is linear and binary search. Let's take an example. I am giving you an array of, let's suppose, 7 numbers. This is your array. If I do the indexing, it will be 0, 1, 2, 3, 4, 5, and 6. And I am giving you a key also as an input. K is equals to, let's suppose, 6. And you need to find out if it is present in your array or not. Everyone, are you getting the question? Okay, so what will be the basic approach that you will follow? Yeah, okay, okay. Basically, you will one by one compare 6 with every other element of the array. Yes or no? And as soon as you get, okay, 6 is there, you just need to return yes. Is it clear? Is it clear to everyone? Okay. For that, the simple approach that we will follow, I am just writing a function. Function's return type will be, we just need to return if an element is present or not. So the return type should be, it should be Boolean, not int. Okay, so I am writing here linear search. You will be given the array. And you will be given the size of the array. Okay, as you said that we will loop. So we have to loop the entire array. Yes, no? Yes. So we will start from 0th index. It will go till the length of the array and I plus plus. Coming inside, you need to check, am I missing some parameter? Flag, no, not required. Anything else am I missing? Yeah, correct. Many of you didn't figure it out that we are writing this entire code for finding the element, right? We need to find if k is there or not, but we are not even sending k into the function. How will you find that? Getting this, everyone? Yes. So here you will check if your array of I, the array element, is equal k, then in that case, you need to simply return from here true. Flag is not required. You can simply return true directly. It's not required, Vishnu. You can directly write array.length, but if n is given, why not use it directly? Okay. And in case like this entire loop finishes off and this condition is not even executed once, then what should we return? If you didn't found your element, what should be returned? False, correct. So at the end, you need to return false. And close your bracket. Is it clear to everyone? Okay, that's great. So now you must realize this, that there can be k which is equals to, let's suppose I am saying 9. Okay. If it is 9, then it will traverse in the entire array. Yes. And at the end, it won't find the number. Yes or no? Yes. So ultimately, it is traversing the entire array at the end. Yeah. And there can also be the situation which is like your first element itself is your k. Like, let's suppose if I'm searching for 7, I will find it in the very first element and I will return yes. So basically, here are three cases which you can see in this. One is best case, one is, you can say, worst case, and one you can say medium case. So what is the best case scenario? The best case scenario is when k is given to you as 7, first index, or you can say 0th index, right? If k is 7, it is the best case scenario. What is the medium possible scenario you are finding here? Medium case scenario is not actually the middle element. I will say all the elements after your first element comes under the middle case. Okay, middle case elements. So I will say starting from index 1 till index 6, all the elements come in this case, because at least you have a possibility that you are finding your answer. Worst case scenario. Worst case scenario is that you are not even able to find your number, like 9. Okay, in case of 9, you're not even able to find the number. Hence, in that case, sorry, that case comes under worst case scenario. K doesn't exist in the array. Clear, everyone? Okay. Now, if you see for the best case scenario, it is just executing for one loop, like one time only, then it is returning. Yes, no? Yes. Hence, when things execute in like fractions of second, or you can say just a simple condition check is followed and the thing execute, in that case, we call the time complexity as order of 1. I have not yet explained what is time complexity, but I'm giving you a very, very rough idea that how we can actually check that. Clear, everyone? Everyone, are you clear with this? Okay. Anyone having still any questions? Okay. In the medium case, you can see that your number can be either on the second, like on the first index, or it can be in the sixth index, right? It can be anywhere. Hence, you may end up traversing the entire array, right? And when this is the case, your time complexity becomes the number of iterations you are doing. Here you are doing one iteration, so order of 1. Here you are going to do almost n number of iterations, right? So it becomes order of n. Clear, everyone? Great. this value is almost considered as a constant value. Okay. So if sometimes you see, okay, someone is using an if condition, or someone is using some kind of if else, you can probably say you can if else, or you can say ternary operators. In those cases, the time complexity is constant. Clear? Okay, great. In the medium case, you can see order of n. Order of n means as the size increases, like you can say array size increases, so as the value of your time complexity, more the time it will take to execute. Clear? And same goes with your worst case. Worst case in the sense, obviously it is iterating n times, and at the end it is showing that, okay, the number is not found. Again, it will take order of n. Everyone in the class who are still hesitant in terms of whatever I have explained in terms of time complexity. I am going to explain time complexity in a brief, but right now, since this question requires slight knowledge of the time complexity, I'm telling you all. So, how many of you are still confused with what I said? Clear? Great. Anyone who is having the questions? Okay. So, the overall complexity, if someone talks to you that you have written this program in an interview and interviewer asks, okay, tell me the time complexity, then you always need to tell the worst case time complexity, not the best case. Clear? So overall time complexity of this problem is order of n. Clear to everyone? Okay, that's great. Why worst? Because in worst case scenario, you know that beyond this, your time cannot go, right? In the best case, you know that only for the best case it is working out this well, but for the worst case, you never know. So worst case always works because you know the limit. Okay. So now you learned about the binary, like linear search. Now we are coming to the binary search. Has anyone heard of this term before? Okay, one yes, two. Can like you all can give small definitions on the chat box as well if you are aware of this. I'm giving you 2 minutes of time. Just post your answers in the chat box. Asking about binary search.
Hello.
Yes.
Yeah, ma'am. I have a confusion in linear search. If the element is found at zeroth index, then the time complexity is O of 1. And if the element will found at one index, then what is the complexity? O, o of 2 or O of
It's
1?
see why I say this as order of one, to show that you know that when I say that okay, this particular thing is executed in 1 second, it is almost considered as a constant value, right?
Yeah.
Like if I ask you, okay, is your name Aman or not? So you will be having only just answer like yes, yes or no, right? Correct? So it executes very fastly, yes or no?
Yes.
But in the you can say the medium case, do you know that where your element belongs to? Is it on the first index or is it on the sixth index?
No.
No. So in that case, you need to be dependent on your n, right?
Right.
Like in the worst case, you will end up traversing the entire array, right? Hence, its complexity is order of n.
Yeah.
Clear?
Yeah.
Okay. Okay, so I have got answers. Let me just quickly read that out. Sorted arrays is in the tree format, not precisely. Sorted array is fine. In binary search, we will divide elements by 2. Okay, dividing the array. Then search is just for the requested element. Okay. It is a searching technique where we can find the element from the sorted list by dividing the list into half. Basically, we keep on dividing the list into half. Not just we divide it once, but we divide it multiple times. Find and sorted arrays. Yeah, okay. Take the middle element. Okay. Good, Richa. You have actually explained it that we have to take the middle element. If the value of the search element is less than that, then we have to narrow down our search. Good. Plus points for that. Okay. So basically in binary search, our first, you can say prerequisite is that the array is sorted. Okay. If your array is not sorted, then you cannot apply binary search to it. So here I am taking a sorted array. Let's suppose I am taking a sorted array. This is your sorted array. Let me write the indexing. And I am giving you the key value as 9. Okay. So considering it is a binary search, what we will do, we will first of all, instead of like starting from the here, the zeroth index, we will start from the middle element. What is your middle element in this array? It is 6, right? 6, or you can say the number at index 3. So we will find our middle index here, mid index, which is 3. And you will check if your middle element is equal k. Okay. Is your middle element equal k? No. So our next condition is, since you know the array is sorted, you will check if k is greater than the middle element or k is smaller than the middle element. Are you all able to follow this? After checking if middle element is equal k, if this doesn't work, you need to check if your array of middle element, let me just, instead of k, let me write it as m. If your array element is less than k, okay, then should we search on this part? In case if your search element was, let's suppose 2. So should we be searching on the bigger part or on the smaller part? Bhuvnesh, I have given you an example that if your k was 2, in that case, what would you have done? Smaller part or, yeah, correct. So if it is your, you can say the number is smaller, then you need to go to the left side. Clear? What does it mean to the left side? How will you indicate that? How will you know that, okay, previously you were searching from here to here, But now you have to search from here to here. How will you make that partition? Good. So now I will introduce to you all three variables that we use in the binary search. Like you can say it's the soul of binary search. We consider that this is a particular region, this and this, where we can find our element, right? Initially, you know that your element will exist between these two elements only, yes or no? So since this one is the lower index, I name this particular index value as low, and I name this particular index value as high. Clear? Is it clear, guys? The next thing is, if you need to find the middle element, you know it will be high plus low divided by 2. Clear? And hence you will find your middle element, or I can say middle index. If in case your array of mid is less than k, now you know that this particular region is not of any use, yes or no? Yes. So now your high should move from here to here, correct? Because now this is your region of search. Hence, I will change the value of high to what it should be changed to, mid minus 1. This was your middle index, so it should be mid minus 1, or I will write it as m minus 1. Clear, everyone? Great. Next is, if in case your value, sorry, I'm wrong. Yeah, if in case your k value is bigger, okay, like here, k value is 9, which is clearly bigger than your middle value, that was 6. What should be done in that case? In that case, you should update your low to mid plus 1. Clear? It's just about like changing your boundaries until you get your answer. Clear, everyone? Okay, great. So now let's just focus. You all got these three conditions, right? One is if it is equals to k, otherwise it will be less than your array of mid, or it will be greater than array of mid. Yes. Anyone confused with these conditions? Okay, then let's just quickly take an example of our 9 here, and I will make here 3 values. One is your low, then it's your mid, and then it's high. Okay, and the number is 9. So initially your low was, what was the value of low? 0, correct? What was the value of high? Always remember that whenever we are in the array moving, we should always consider indexes rather than taking the numbers. Okay, because while you will be changing your middle value or the high value or the low value, it will be very difficult. Clear? Great. High index is 6, and calculating your middle index will be 3. Correct. Now you searched at array of 3. Did you found? Let me just write here. Did your array of m is equal k? Yes or no? No. Now, next condition. Is your array of middle value is less than k, or what I can say, your value is greater than array of middle? Yes or no? Is your value is 9, okay? Is your value greater than array of mid? Vishnu, your k value is 9 and your array of mid is 6. So obviously it is greater, right? This condition is satisfied. If this is satisfied, what should be done? Which value should be changed? Low value should be changed, right? So your low here will become 4, mid plus 1, right? Your high will remain as same, that is 6, and your mid will become 5. Now, again, this condition will be checked. Is your array of m is equal k? Yes or no? Yes, okay. So here directly yes will be printed, or you can say here directly true will be returned. Clear to everyone how this is working? Okay, great. Now we will take the same example, but I will take a different value of k, and then we will see how it is running. Let's take your k is equals to -7. Let me just write. It's -7. Okay. Then what will happen in that case? Again, your low will start from 0. Your high is again at 6. Your mid will be 3. Yeah. Is your array of mid is equal k? No. Skip this part. Is your k value greater than the mid value? Your middle value is 6 and your k value is -7. Is it greater? No again. This condition will also not be fulfilled. Then comes your next condition where your array of mid is greater than k, or your k value is lesser. Will this condition execute? Yes. Moving forward, what value will change, high or low? High value will change this time. What should it become? What will be the value of high? Mid -1, that is 2. Now your low will remain the same. What will be the value of mid now? 1. Executing this condition again. Is your array of mid equal k now? Your array of mid is now -1. Is it equal? No. Is your array of mid less than k, or you can say your value is greater than array of mid? Your k value is -7. Is it greater than -1? No. Is your k value less than -1? Yes. So this will execute. Which value should change now? Okay, now the value should change of high again. So your high will become mid -1, that is 0, right? Your low will also be 0, yes or no? Okay. What will be the value of mid now? 0 again. Will first execution will the first condition execute? Is your k value -7 equal to -5? No, not executed. Now, is your middle value, that is -5, is less than -7, or -7 is greater than -5? No again. Is -7 less than -5? Is -7? Yeah, right. Again, your high will be updated, yes or no? Yes. Once it is updated, your high value will now become -1. Your low will remain the same. And now the question is, should we continue further the search? No. So now from here, can you all tell me the breaking condition for this particular binary search? Like you all know, we have to continue searching in this binary search, but when to stop? Think that what condition can it be, and you can put your suggestions in the chat box. Vishnu, think properly once and then give the answer. Okay, Bhuvnesh, for you, I'm giving you a test case. Let's consider my k value is 15. Okay. And what condition you have told me, will it work with that? You try it once and then tell me if it is working or not, okay? K equals to 50 also works. You can check for that. Yes, guys, I can see only 3 people have given their responses. What about you? Okay, 4 people. What about the rest? Vishnu, one tip for you. You should never be dependent on array value for the conditions because you never know what values are going to be. You should only focus on the indexes while you are writing the condition. Good, Bhuvnesh. And Vaibhav, tell me the condition when you don't know what is the size of the array, okay? In that case, what will you do? That I am asking. Okay, so let's quickly see it. You all saw that it was continuing until your low value was like smaller than high value, right? Or even equals to. Are you all getting this? And as soon as it became greater, like low became greater than high, then the condition stopped. Yes or no? You can see that your low became -1 here and your low was 0. Like high became -1 and low was 0. So you need to break from the loop. Clear to everyone? This thing? Okay, so writing a proper code for this. Does anyone want me to write this in the IDE? Okay, one person said yes. Okay, guys, do the voting. So I'll know. Only one yes, one no I've got. Two yes, one no. Okay, majority is saying yes. So I'll just share my screen and write the code. Just give me a minute.
I mean, day to day, should we prefer to write on HackerRank's platform or on Eclipse?
What I will prefer is just a minute. What my preference is Eclipse, but like generally you are like when you're doing the competitive coding questions, it's a recommendation that you should be doing it directly in the ID of HackerRank or HackerEarth, whatever you are solving the question in. Because like in an interview, while you are using the Eclipse, you get habituated to the shortcuts and all. Okay. So while writing the code in an interview, you face a lot of difficulties. So that problem shouldn't come. Clear? Okay. Okay, everyone, are you able to see my IDE screen? Yeah, now I'm sharing my screen. I hope everyone is able to see that. Okay, so I'm taking an array of sort 7 numbers, which is going to be sorted. And I will pass. Okay. I need to give a k value as well. So right now I'm giving a value for k as 8. And I will call a binary function. I will directly print its output. So I'm writing system.out.println here directly. And I will write binary search function here itself. Pass my array and the k value. Clear to everyone? If you want to write it in a better way, you can just remove this. You can take here Boolean result and then print your result. That will look good. Now writing the code, as I told you, that the breaking condition, or you can say the looping condition, was until your low is either less than or equals to high. As soon as it becomes greater, we need to exit the loop, correct? Everyone able to follow that? And before that, you need to initialize your low value as 0 and your high value as your array dot length, whatever your length is, minus 1. Everyone is able to understand why array dot length minus 1 and why low equals to 0? Okay, great. And just initialize your mid also here, like just declare your mid also. The value will be initialized inside the while. So your mid will be equals to low plus high divided by 2. Clear so far? Okay, great. Now we will place our 3 conditions here.
Ma'am,
Yeah.
once more, I always had a doubt that when you do not initialize mid, it will give compiler error. So
No,
is
if we directly place a condition for check of the mid before initializing it, like let's suppose I just directly come into this loop here and I just write here if array of mid is equal k. Okay, this is going to give you a compilation error.
okay,
Clear?
okay,
Yeah.
okay.
So here you will check if array of mid is equal k. In this case, you simply need to return true. No need to think much. There will be a condition else if. In that case, you need to check if your k value is greater than array of mid. Okay, if your k is greater, where should it go? Towards the left or towards the right? Towards the right. So your low should be updated and your low will become mid plus 1. Clear everyone? Now you can see that 2 cases are covered. One is equal to, one is greater than. So only one condition is left. So it will covered by else condition and you will be writing here your high is equals to mid minus 1. I hope every one of you is clear with this. All right. Any confusion, guys? And at the end, if you are not able to find your value, then you need to return false. Yes. Any questions in the given code?
I have one question.
Yeah.
Uh, like if the element is not there, like when we are searching, And the last time when you were putting on the whiteboard, the medium was returning -1, middle element was like -1, and the low element was 0. Then you had put the condition as when low is greater than high.
Your middle element was -1 or your middle index was -1?
Middle index was -1.
How an index can be -1?
Oh, and like the in the whiteboard, you're trying to explain with the diagram, like
You can
mm,
see here. Okay, this is the
yeah, like
diagram.
green color. Yeah, this green color when low is
Yeah.
greater than high. So this condition I don't see there.
Okay, you can see here in the first. Low is 0 and high is 6, right?
Yeah,
Consider this in a way that someone is saying that a thief is there in between these two boundaries, okay?
yeah,
So you will start looking on to that, okay, I will look only into this boundary, clear? Will you look outside of this?
no,
No. Now, your low was at 0 and your high was at 6, clear?
yeah,
You sent one of your, you can say, commander in the middle of the garden, you can say, to
yeah,
find if the thief is there or not. Okay. He says that no, he is not there. And even he cannot lie here because the entire ground is clean and I cannot see him. Are you
okay,
getting my point?
yeah,
So now, will your entire force search for the thief on this side or this side?
left side, yeah,
Obviously on the left side, right?
yeah,
Now, when you're looking for him here, again, you goes to the middle of it to check
okay,
if he is there or not.
yeah,
Okay. Again, if you're coming here, again, your commanders are saying, see, he is not here
yeah,
and he cannot even lie here because the ground from our end is clear. We cannot see him.
yeah,
Okay. So again, this will be your boundary limit.
yeah,
Now let's suppose the next time your commander reaches here and they say, no, the thief is not here.
yeah,
So you have ultimately searched in the entire boundary.
yeah,
Now, only way for you to search is beyond this.
yes,
That means when you were here, your low and high were both were here, right?
okay,
Correct? Like you
yeah,
are continuously changing your boundaries, right?
yeah, 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 yeah. Both are,
And when you go beyond this, like I have written here, -1, because what happens here, your high becomes mid -1, right? So mid
okay,
was 0, so high
yeah,
become mid -1. That is 0 -1, it is -1. Clear?
okay, okay,
So
okay,
now your boundary is being crossed. You can clearly see you have searched in the entire ground and you have not found it. Then in that case, you need to return false, right?
okay, okay,
So in the entire case, what you saw, low and high were moving. But in every case, your low was less than or equals to high, correct?
yeah, yeah,
But as soon as your low became greater than high, as you
yeah,
can see in this case, low was 0 and high is -1, then in that case, you know you have searched in the entire boundary, right? And
yeah,
hence you are not able to find the number and you return false.
yeah,
Clear?
yeah,
Is it okay now?
yeah, clear.
Okay.
So if you go back to the ID,
Yeah.
I want to see when low is higher than low is greater than high.
See,
Where do we?
I have just written in the condition that you just go into this loop if your low is less than or equals to high. As soon as this condition is false, you get out of this loop.
Okay.
Clear?
Yeah.
Okay.
Yeah, no, it's clear. But
Everyone else?
where does
Yeah.
this bracket end? While I want to see if you put
Yeah. Yeah. Yeah.
okay. I name clear, 100% clear.
Anyone else in the class who is not clear with the concept of binary search so far? Okay, I'm assuming that to be no. I'll just run this particular program and see. Okay, where is this? Okay, I've just forgot this. It is returning true because you can see I've given k is equals to 8 and it is there in the list. If I give, let's suppose, 17 and run this program, it is giving false. Everyone, are you clear? Let's try giving one more number, middle value, or let's try giving it as -5 or -6. Run it, it is again giving false. Everyone, are you clear now with the code of binary search? Yes, no, I cannot see anyone's message. Anyone confused with the code? Yeah, Bhuvnesh. Okay. Yeah, correct. If elements are not sorted and you need to apply the binary search, then you first need to sort them. Should I now switch back to the whiteboard again? Everyone is done with the question? I mean the code. Okay. Now we have discussed binary search. We have discussed linear search. You also know the complexity for linear search, but we don't know the complexity for binary search. Okay. So I am not picking that topic today, but tomorrow we will see the comparison between linear search and binary search. Okay, we will see which one is efficient and which searching technique we should use and when to be used. Okay, then I will end the class for today and we will meet tomorrow.